My name is Charles Johnson. I'm a principal consultant with Metron, the state's part, the Metron Athene or Metron Technology Limited here in the UK, our headquarter, our parent company. I've been in the IT industry for, I'm going to say 35 plus years. So I've been around the block. I've been with most of my career has actually been as a customer as opposed to be a vendor. So if you look at the split, it's been like 70% customer, 30% vendor out there. All large organizations from insurance companies to outsourcing to payroll and automobile. I'm from the Detroit, Michigan area, so if you haven't done anything with automobiles and live in Detroit, you haven't been there that long, so especially in the IT industry. One of the things that follows on to the session that I did yesterday was a newbie session for capacity managers, how to get started in capacity management. And this is a good segue into the next step is how do you get into modeling? And the key point in creating a model or being able to do your capacity planning is a baseline. Because if you don't have that baseline, if you don't have that starting point, you're going to be lost. Your whole analysis point from that, the analysis from that point on is going to be lost. So that's what we're going to do today is talk about analytical modeling, which is one of the prevalent ways to do modeling. I want to say preferred ways to do modeling in the industry, and how you go about creating effective baselines. Now, I don't have a strict line that says for a baseline you need to do this, 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 and this. I have those within there. But this whole is to give you some of a workflow, a working idea of what you need to do in order to create that information and get that baseline. And again, throughout the presentation, if you do have questions, please go stop me and ask me. Okay. The agenda, we're going to talk about modeling tools and techniques. What information do I need? What questions can a model can answer? All right, so you're starting to look at it in the standpoint of, I need to do what? Or what is this supposed to do for me? Determine the baseline for the modeling question. Some of the ideas for you to look at in doing that. We're going to go through one ZOS modeling scenario within that. And then just a recap for this. Okay. This was a definition that I found out on the net about modeling. And I thought it was very concise in what we're trying to accomplish with it. A model is a simplification of reality built for a specific purpose. So if you break that down, a model simplification of reality, so you have these components, discrete components that you need to gather information on in order to model. And the reality is what is happening at that point in time. The specific purpose, it goes back to the question of what am I trying to answer? What is the question I'm trying to answer with this model? Oh, that's the whole point behind this. So that's where this statement came from. When you start getting into this, you start asking, what questions can a model answer? You need to be able to understand this in such a way that there may be questions that for a capacity manager that people ask you that models may not be able to answer. You may have to do other types of techniques, trend reports, statistical analysis, those types of things. If you look at it for capacity management through this all-encompassing point of view, capacity management is about forecasting. It's about being proactive out there. So within this whole paradigm of capacity management and forecasting, you have different techniques. As I said, we've got modeling, which we're going to talk about today. You've got trend reports. You've got statistical analysis. You've got we're going to talk about simulation modeling here also. So those are the types of activities in which you will do within the capacity management arena. And so you have to figure out what questions you're going to be asked that a model can answer, such as, where are my current bottlenecks? All right? You're running reports. You look at a specific interval of time. Where's the bottleneck, or what is the bottleneck out there? How can I increase the amount of workload within the environment, and what is its effect on the response time for the end users? In the modeling scenario, I like to call response time. Take that out because it's got so many different meanings by people of response time. I like to call it, and we call it within Metron, the quality of service that we're giving to that end user. All right? So whatever type of activity that they're trying to perform, what is the quality of service that we're giving to them? So in essence, the response time in many ways. How much more work can the system handle? What is the degree of tolerance in a forecast? Are we going to be 100% spot on? Maybe yes, maybe no. The more you get comfortable with doing modeling, the more questions that you ask, the more information that you can feed in to a model, you become more and more accurate with your assumptions and the information out there. How sensitive is it to workload increases or the workload growth estimates? Taking that into account, again, it goes back to talking to the business units and understanding from their standpoint, from a business standpoint, what it is that you're trying to increase for the business versus the technical standpoint. So that one is specifically focused at, from my standpoint, or looking at it, is what is the business looking at from its growth projections? And you're finalizing and you're fitting that in to the activities. And then the last piece is mostly related to money. When do I need to upgrade, and what performance benefit will I gain from this? In capacity management, you always want to make sure that you have enough resources to handle the workload. That comes underneath a term in ITIL called demand management. But you want to make sure that you don't have so much extra room out there, extra capacity out there, that you're just having unused money basically sitting on the floor. So you want to be able to have enough to manage the workload. You don't want to run too close to the line, but you don't want to overextend yourself in the amount of resources that you have on the floor. So that's what a model can answer, and that's what I call the money question. In doing baselines and in doing modeling, again, it's always a balance between the amount of service that we're going to provide along with the cost of that service. So we're balancing that all the time and looking at that. Users may come to you and say, I want sub-second response time for all my transactions. You look at them and go, do you know what this is going to cost to do that? But you can go back to them and say, this is the cost to do this. Now let's start thinking about this. Should a query transaction be sub-second? The answer is probably no. If it's a query transaction that's being done by the call center and you have someone on the phone line, that's a different question. Okay? That's a different situation. So you're looking at that, so you're balancing what it is, the service versus the cost. It's funny whenever he walks into the rooms and everything like that, I keep going, that's my camera. Because I have the exact same kit that he's got there at home, within there. So I'm going like, oh, okay. Now we're going to talk about modeling tools and techniques out there. A tool that can be used out there is the vendor. Having someone come in and analyze your environment. Having a consulting activity go on within the environment. So, it depends on who's doing it. It depends on if they have any objectives that they haven't told you, like they want to sell you something more, that type of thing, so their capacity. So you yourself have to understand what their objectives are, but you do have vendors out there that can do it. Tools and techniques, you start looking at, do I want to do trending? Is there a consolidation going on? Whether that trending is positive or negative. All right, you're looking at it that way. Versus consolidation. Within the United States, there's a lot of mergers and acquisitions going on within companies. So the IT industry is the number of IT shops are shrinking, but they're actually a lot larger than they used to be out there. So as opposed to little ones, you're having a lot of consolidation going on. So you need to fit that into your tools and techniques that you're looking at, which brings us to this point of the three major areas that you're going to talk about with modeling. Today we're concentrating on analytical models. I have a screen that talks about simulation models so you can understand a little bit what that difference is. And then you can also do benchmarks, such as, what have other organizations done? There's always benchmark information out there with various vendors, various companies. IBM's got benchmarks out there. There's user industries out there. You've got forums out there that talk about what they've done, companies have done in that area, so that you can use that as information. So, by going back to this, that's the whole encompassing thing. So, the whole point behind this screen here is when you get to modeling, deciding what is the appropriate skill set or the appropriate technique that you're going to use. Well, let's talk about more details about what analytical modeling is. Up in here, this first statement is, this is the technical piece of it. A multi-class queuing network theory, stable and well understood, operational research laws applied to computers, known as the queuing network model. It's also involved, you'll hear about Little's Law and everything like that. To break it down, analytical modeling is looking at the arrival of work onto a physical platform at a certain period of time. Very simple. So how much work is getting put onto that platform at that point in time? That's the way that I simplify it down. So because of the way that analytical modeling works, you don't have to be, you can start as a novice and start playing around with it because it's very easy to do. It's very easy to start doing what-if scenarios within that. It's easy to understand the interaction of the physical components. The accuracy, once you start understanding how the model works, you're able to get quite a bit of accuracy. We've done large consulting engagements out there using analytical modeling, and we've come within 98% of the real world. So it goes, and how do we do that? It goes back to asking the questions and getting that information and feeding that into the model. You have fewer metrics as long as you are collecting the data automatically. You don't want to have to be out there and all of a sudden someone says, I want you to model this particular scenario, and you have to go start gathering data. If you have an automated data collection mechanism, take that in and bring all that data into a centralized capacity database, that's going to be your key to your success. Few parameters for the what if changes, and then it's very quick to do what if scenarios. What happens if my CICS workload increases by 10%? Okay. What happens if my I/O configuration changes? Those types of activities, you can see very quickly the impact of it. And then the sensitivity analysis is how close, and this comes from history, your historical, how close are you to the real world? In a model, it's very critical to, after you have taken that model, you've presented that, and you said, okay, this is our forecast going forward, is to take the information, the real information, for that same period of time that you forecasted and say, yes, my CPU utilization did hit 95%. My I/O did look like this. The queuing for my CICS workloads did look like this. So then you can start gaining that accuracy, that sensitivity, and you understanding the correlation between these activities out there. And that's what the analytical model will do for you. The pros and cons of it: it's accurate enough for most planning purposes, quick to build and get the results, does not require the detailed expertise. The one gentleman in the back yesterday in my newbie session asked about how do you get started in this whole process? And as I said, just doing it. And you start looking at the data and understanding the data out there. So that's one of the key P's out there. And you can completely produce repeatable results out there. That's the other nice thing about analytical modeling. If you enter in the same intensity values for the workloads, that's one of the key terms that you'll hear doing analytical models is intensity. Intensity is the increase of the workloads over a period of time as it arrives, is you'll get better in understanding what's happening there. The cons: limited specific workload mixes at a single point in time. And we're going to talk about, and that's where it starts getting into what the baseline is. Well, how do I derive that baseline for that particular environment in answering that question? And I'm going to keep circling around to this is, what is the question that I need to answer? What are the changes that are going to be in there? And then creating that baseline. So you pick a representative period of time. And we'll talk about that in more detail in just a minute. The whole point behind analytical modeling is this graph. It's the quality of service to the stakeholder, whoever that stakeholder may be. And the whole key point behind this is, as your workload increases, if you don't make any changes to the environment, a workload will probably at some point the quality of service starts decreasing. So as these bars are going up, means the quality of service is decreasing, to where exponentially it hits what we call the knee of the curve. Okay? To where, you might as well shut down, all the lights go out, no one can do anything. So analytical modeling helps you understand when you're going to hit that knee of the curve, or another term that you'll hear, that saturation point as it moves forward. Simulation models. Just a couple of minutes on that. You'll hear it talked about as a DES, or discrete event simulation. There are industries out there, and I point to because I have friends in this industry that do this all the time, such as the financial and the stock markets. They actually have a duplicate production environment out there sitting within the off-site that they analyze and make changes out there. So you basically, a simulation model is taking your current production or environment, duplicating it, making those workload changes, trying to figure out automatically, such as you use, there's various tools out there to simulate additional workload coming into the environment and seeing what kinds of changes that happen within the environment. The key to that, or one of the keys to event simulation, is it's highly accurate. You know exactly what's going to happen as long as you have many key components. But it's a lot of expense. It takes a lot of time because you have to make sure that your environment that you're using to simulate matches identical to the environment that's in production, and that the workload changes and the workload activities are the same. So it takes a lot of expertise to do this. There's a lot of people that make quite a bit of money that go out and do this for large organizations. But for some industries, it's required. You've got to do that in order to make that happen. So the pros and cons of a simulation model: accurate if set up by an expert, can model behavior over time because you're keeping that environment and you're constantly making changes within that environment. You can model the detailed system internals. You know exactly what the operating system is doing. You know what that LPAR is doing. If you go in and make changes and go from, let's just say, ZOS, 1.3 to 2.2. You know what the types of interaction or what types of potential changes could be. That type of thing. If you decide to change releases of DB2, as IBM continually evolves these operating systems and these components, it's more and more how can I take advantage of the machine? So that's one of the things that simulation modeling will do. I'll help you with that. The cons: if you get pieces wrong, you're going to be very wrong out there. It's hard, and it's hard to get back to your starting point. It takes a lot of expertise, time and effort to set up, those such a thing. So again, it's not to say that simulation models are bad. It's just to understand that it takes a lot of time to do an accurate simulation model. Okay. One of the questions that I always get is, and the reason I say forecasting when I talk about capacity management as opposed to modeling just itself, is many people lump in modeling as both the technical modeling and trending. But I wanted to break this out just to be able to show you where the differences were, or what some of the differences were between trending and modeling out there. So trending is easy to do. You can take the data into a product. IBM's got a product. We've got products. Metron. You have your Excel spreadsheet. Take the data in, create a trend chart. Boom, you've got the information. You can scale it to multiple systems. You can see alerts out there. Those types of things. The third or fourth topic there, no relationship to the performance of a system or an application, is because you're taking one metric, and you're just doing that trend on that one metric. So there's no interaction out there. So that's what that means. Modeling relates to services. Services are made up of the components out there. Those components meaning the CICS transactions, the DB2 information that's going through your environment, the LPARs, the IO. Those are components out there. So modeling takes into that utilization and that interaction out there. ITIL recommends you to do modeling within capacity management. And again, it's just a moderate effort. But again, the one key takeaway, the one key difference between trending and modeling is that trending is focused on one metric. That's all it's doing. You can do statistical analysis and do other kinds of things, but if you're looking at it from a base point of view, it's looking at it from one metric. Modeling is the interaction of all the workload components going in to that environment at one point in time. Okay, so how do we do this? How do we do this analytical modeling thing out here? And this was a workflow chart that was originally got the original information from one of our partners, our partner in Japan, and then I modified it some, adding some of my own items to it. But the workflow is you take the technical and business inputs from the current system, the current information, and you measure and compare it with predictions that you had previously. Okay? That's always, I think it's critical to do that. See how close your previous model was to the actual real world that you're in right now. Once you take all that information and you have a comfort level, you start building that baseline. When you build that baseline, and you'll see in just a few slides how, what type of information you want to look at in order to build that baseline or determine what that baseline is going to be, you build and calibrate the model. So the building of the model is taking all that information, taking all the components, coming up with the model, but you have to calibrate the model. If you don't, what calibration of the model means is, are there pieces that weren't taken into consideration when you brought that information into the model? So you bring in all that information in, and the calibration is basically a statistical analysis of the baseline model saying that, yes, I can account for 99 or some odd percent of the workload activity out there. If you're missing a piece, if your IO is way off, those types of things, you'll see that when you calibrate the model. Once you do that, then you can start coming into the next section of it, of the inputs. So those inputs are the information. The CTOs come to you and say, we're going to have this change within the environment. The business units are coming in and saying, we're having this change within the environment. You start bringing that in. You start looking at the expected configuration. I always like to do modeling, the analytical models, in steps. So you build your baseline, you look at that, and then you just take that straight baseline and project it out for X number of projection points. So there's your baseline. Then you say, I'm going to add this workload, or I'm going to increase this workload, or I'm going to decrease this workload. So then you see what that effect is within the environment. And that's the modify the model and the projection model. So that's where you're taking that information and you're going, okay, you got the baseline, all right? You make changes. You may saturate, or you may come to a point where a particular workload or in the particular environment cannot sustain the workload. That's called the saturation point. Then you have to make the changes. What do I do? Do I change the CPU, the processor configuration? Do I change my I/O configuration? Those types of activities. I want to say funny thing, but many times when you resolve one bottleneck in a model, there's another bottleneck that's sitting out there. That all of a sudden, once you solve that one bottleneck, you'll see another bottleneck out there. So you're continually looking at that and solving bottlenecks. So you can look at analytical modeling and from the baseline of how do I solve these bottlenecks or resolve these bottlenecks as you move forward out there. And then the last piece is what is your new actual configuration, and measure that and compare it against the predictions. It's very critical to do that analysis. So now we start talking about these baselines, that first level of what is the information that I need? You're looking at service level agreements out there, service level objectives. You're looking at KPIs or key performance indicators or CSF, which is the quality of the critical success factor, kind of like a KPI. So you're getting that information, how it's created or what it is within your environment. It is very critical that you talk to the business units, you talk to the business owners, those stakeholders. Get their take on what's going to happen out there in the future.
Charles, I mean, it's interesting, you know, your last slide really reminded me, I was saying we held a couple of meetings in between this conference and last conference, and back in June, the meeting I was showing you the photos of before, Sandy from Lloyd's had done some modelling to try and understand the business input, the amount of business input. I don't know whether any of you guys were involved in that, or whether you still use it. But it seemed incredible to me that he'd managed to take, I think, a number of business transactions that they were going to get coming into the bank. Mm-hmm. And he managed to find a way to predict the bank holidays, you know, how that would affect demand, on what day of the week the bank holiday occurred, you know, which bank holiday it was, whether it was Easter or Christmas or and that kind of thing. And he'd sort of done, you know, one iteration of that. With 3 years data or something, and it, you know, he'd worked out where it slipped. I know this is only on business transactions rather than actual throughput on the machine.
Right.
But it meant that he could then predict forward. They got to the point where it was very, very close to what was actually happening. Exactly. They'd worked out, you know, what day of the week a bank holiday was on, and, you know, end of month and all those kind of events. And every time they tweaked it, they managed to tweak it up. It's all within Excel. And in the end, it meant that they could. So he managed to predict in the past from the data. But then when they looked into the future, it was beginning to predict what the future was. Really, really well, and it was a very, very interesting. It was two sessions. There was the session on how they've done the modelling, and then the session on how you do that in Excel, which is way beyond my Excel skills.
I've done it.
Some of the stuff that he was doing in Excel, that you could do that in Excel.
Absolutely. It's in the beginning, before we had some of these sophisticated tools and products out there, I've had to do that. You start doing pivot tables and this and regression, and it gets complicated. It's like it is writing code, you know, to do that. But a lot of that was the basis, or they actually input, and I saw that presentation, some of the pieces of it. Someone else showed it to me, but the interesting part about it is they took the philosophy of the queuing network model into that spreadsheet. That's how they were able to do it. the Little's Law and everything. It wasn't taking the actual numbers and the calculations, but it was the philosophy that he took into that made that happen, make that work. So, but thank you for, that's.
Yeah, I mean, really, that was also partly a plug to say we're going to have, meetings in the interim before next conference. So keep people, think about presentations you can do in the future. That'd be great.
Yeah, and you may see me back. You may have to be actually, I think probably I will be back. And Ian's looking at me back there going, yeah, he'll be back.
You may have to emigrate soon.
Pardon me?
You may decide to emigrate.
Yeah, that's true.
If it all goes wrong.
Yeah. Talking about from the business units about new applications. And then the other item here is talking to your vendors. Do they have new hardware that's coming out that may help you, What is the infamous, the Z14, what is it going to look like? From the Z13 that everyone's migrating to, or Z15, or doing other things out there. What is the new, I/O? They're doing a lot of work in the area of channels and in that area to be able to speed that up out to the outlying SAN environment. So look at what that information is going to give you. The next part of it is determine the baseline for the modeling question. And you're going to see some charts in just a minute that relate to similar to what John was just talking about, within that. The time of duration, looking at your peaks, when future problems are going to happen. Making sure that when you pick a particular time frame for your model, that all the important workloads are present in that particular time. If you're looking at your environment and I'm going to do a model projecting forward, and you say, our highest CPU utilization or our highest I/O utilization, let's put it that way, is actually at 3 a.m. to 5 a.m. in the morning. Is that really a good time to predict your model, knowing that your onlines run from 8 to 4? So, so you're looking at it that way. So along with that, no external events such as the U.S. election. Things are going to go bananas. We all know that many of the financial sectors, they've been gearing up for this for 6 months because they know that there's going to be changes. There's going to be, the stock market's going to be flooded with either orders or, buy orders or sells and this and type of thing. And in the United States also, it's really funny. The gun manufacturers are gearing up because, the increase in ammunition. Okay, that's going to be affected by that. So you're looking at those types of things. The next 3 slides here are helping you graphically look at what types of information that you're going to gather for creating the analytical model. So choosing the peak on the period of time, you can look at your peaks and your averages. It's good to have them plotted on the same chart. Okay, so you can see for that particular time that you think you're going to model, are the peaks greater than the amount of the peaks and trending that forward are greater than the averages. So that will help you pick the time frame that you want to do. Because you look at it, and here, you'd not want to pick that point in time. Oh, I'm doing the same thing the gentleman did yesterday, making a screen. But you don't want to pick that time as your modeling period because it's not representative. Something happened during that. There was an anomaly. But I would say, okay, here's my peaks sitting out here, so that's the one I'm going to pick. One of those areas. knowing that I have to account for or understand what that anomaly was. So a chart like this, average versus peak trends, will help you. Modeling time of the day. Again, if the questions you're going to ask is, can I handle my online workload, and you pick 3 a.m. to 4 a.m., that's not going to help you answer the question. So, does the time of day affect the workloads? Is the environment transactional based? Is it overnight? So you may actually end up running multiple models. One that's affected, that shows your production online during the day, and one against your batch at night. So you may actually end up with 2 models out there, and that's fine. Some organizations run in a shift perspective, so they have day shift, afternoons, and midnight, or that late night shift. So you may end up with actually 3 models and have to understand the interaction there. So you have to balance that. Say, okay, during the day, we can absorb this workload, our IO looks like this, but at night when batch is running, we're really saturating this particular control unit. So we got to get the IO administrators to go off and see what they can do there to help us better. So looking at the time of day. This goes back to what John was just saying here, the seasonal variation. Looking at the seasonality of that. So looking at the seasonal peaks. So you're trending out the data, and then on there you have the seasonal peaks out there, and you're looking at what happens at what point in time. If your model is, I want to look at my environment and make sure that over the next year I have enough enough resources for that activity, you're looking at it, okay, but we're getting into Christmas season. Black Friday is in 2 weeks in the States. I stay away from the store on Black Friday. I do not go out of my house. I sit home and watch football, okay? So you know that on those days that are leading up to that and Black Friday, you're going to have that peak. So you need to understand, okay, this is what my normal is, but I need to make sure that I'm accounted for that peak at that point in time and say, okay, we're going to have 50% increase. Here's our regular model. This is what we know we're going to do, but we're going to have a 50% increase that day. Companies like Amazon, UPS, Federal Express, they're doing that. They've been doing the models for the past, a couple of months, trying to figure out what it's going to do, what it's going to be. And they're also trying to figure out, like the companies that sell the toys, they're trying to figure out their actually period is 4 or 5 months prior to Black Friday, because they have to gear up and make sure that they have enough stock in store. So whatever the cool Christmas item is of the year. Every year there's always one item that everyone has to have. So you have to take that into account. One of the other items here, and I think is very good to do, is to chart business data versus the technical data. Okay? What that's going to allow you to do is understand the correlation between the two. So you know that if I increase my business transactions by 20%, what is going to be the possible effect on CPU? What's the possible effect on IO? Those types of things. So being able to correlate the business versus the CPU is always good. Any questions about where I've gone so far? Okay. Now so this all goes into creating that baseline model. So that's where we're at to this point, is we're doing that. So the next step is just helping you understand what you get out of that from that baseline model and doing the what if analysis from that point on. During the modeling scenarios, you've got changes in the workload characteristics, changes in the hardware characteristics. You're doing mergers and acquisitions. You may be moving. There's actually, we had a vendor, a company that we sat next to at dinner last night that's actually running ZOS in the cloud. So some organizations are actually taking their on-premise ZOS work and actually moving it to the cloud. So you may do that. I put this in the chart before I talked to them, so maybe I was thinking ahead. But you may take some of your workload, in particular if you're looking at ZVM type of workload on the mainframe. You know, you have your Z-Linux, you have your Linux that you may want to ship up to the cloud, depending on what you want to do. So those are the types of modeling scenarios out there. This is a very simple one here. And it's just, again, to give you an idea of the analysis that you can do in a analytical modeling. This is the baseline. I know this is 13 projection points, whatever that projection point is. That could be quarterly, it could be monthly, however you decide it was going to be. But in this case, it was over 13 months. This is what the CPU utilization was going to be, steady state. This was the busiest I/O device. But the key are the bottom two screens, charts here. Primary results analysis shows you how much I/O busy is for each service class out there, how much I/O queuing was, how much CPU busy is CPU queuing out there. So you're seeing that relatively down at the bottom of the chart. And this, again, it says projected response time, but again, I call the quality of service to the end user. So the next step, the next question was, what happens if we change and increase the production online workload by 5%? You may not think, is it just 5%? It's not a large number out there. But that you can see if it's continually increased by 5% over that period of time, you can see where the CPU is going to where it's almost close to saturation. You can see where the I/O is going, it's increasing. You can see down in the bottom left-hand slide that your your CPU queuing is starting to increase. So you're starting to get throttling happening on the environment. So, what I mean by throttling is the workloads are stopping and starting. They're not able to run as efficiently as they were in the past. And you can see, even though there's not a large increase between a delta increase from the beginning to now, you can see that the quality of service for this particular workload is starting to degrade. So the larger this bar is, means it's a degradation out there within the workload. So even just a 5% increase by this. And then the last piece of it was we changed the CPU out there. We went from a 2827, I believe, 709 to a 714. So we just changed that. And you can see in the bottom left hand, that the CPU queuing went away, but we didn't do anything about the I/O out there. Okay, so we're going to start running into I/O issues. And you can see here, even though we made the CPU change, the quality of service to this workload did not get better. Okay? So what does that mean? That means that there's still more bottlenecks or more items out there that we have to address. So that's the way I do it. Is my whole plan, or the way I attack it, is, again, baseline, increase in workload, solve one bottleneck. You can solve the I/O bottleneck before you solve the CPU bottleneck. It all determined to me by what this shows. But you solve one bottleneck after another bottleneck until you get the environment to go. And the last screen, recap. What is the question that you're attempting to answer? Okay. Make sure that it's clear, that you're clear on it. The end user, the person that's asking you the question, may not be clear, but you have to make sure that in your mind, you're very clear as to what the question is that they're trying to answer. Gather as much information as possible, technical, business data, looking at seasonality information depending on your industry. Those types of things. Gather as much information. Look at each modeling exercise as the ability to refine what I do in the future, the types of questions that I may ask, the types of information I additionally need to gather. That's going to help you with your baseline. When you ask the questions, make sure that you document it. Keep a running log. Say on November 14th, I talked to the manufacturing business manager, and he said this. So that when you're going through this, you understand when he said this, that's how you're translating that information into what you have to do within the model. Ensure your baseline matches the real world. Remember I said that the whole process, you create your baseline and then you calibrate your model. When you calibrate your model, that's making sure that it matches the real world. Because if your baseline model is off completely, you might as well forget it. And think about it this way also. Each time that you do a modeling exercise and you compare it against the current information, and it's very close to what John was saying, what they did at Lloyd's.
Yeah, Lloyd's. You guys aware of that?
Yes.
So how they did that, the closer you get to real world with each of your models, it brings you more and more credibility within the organization. They understand, they say, hey, these guys know what they're doing. They understand not only the technical aspects, but they understand the business implications of any change out there. And that's where you need to do. And that's that last point, comparing your modeling results to the actual time frame. It's very critical that you do that. I've gone into a number of organizations where they haven't done that, and we've started going back and analyzing why their modeling, why their environments were so off. It's because they never did that last step. They never compared it. It gives you the ability to go back and ask those questions again. Maybe I missed something there. That type of thing. So, that's the end of it. Again, please submit feedback for this session here, and it's session LF. And if you have any questions, please, we're open for questions. If anything comes afterwards, please, John.
Yeah, just on, I could see that having a clear prediction of what your business needs were going to be, must be very reassuring. But then it must tempt you to, run the machine very lean, and everything else. And then certainly in the banking scenario in the UK over the last 20 years, we've seen occasions when suddenly the stock market crashes, everybody's buying and selling shares, or the clearing system breaks down overnight, and things then are shunted. So you double, you see a huge increase in the workload. So,
Right.
I mean, I realise people build contingency into these things, but how do you predict those kind of out of
You always, let's put it this way, you always need to have something in your back pocket. Okay? You show and say, this is what it's going to be real world. We can't predict Brexit. We can't, the activity of what Brexit's going to do, or as the clearinghouse, because I remember when the clearinghouse went down, because it had a big effect on the stock market and everything back in the States.
Right.
You can't predict those things, but you need to be able to say, for my industry, what do I need to do if something catastrophic? So that's another model that you may say that, okay, we're at a Z13 XYZ, and we're running here, but if something catastrophic happens, I could go and call up IBM and say, turn on this, 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 and this, and switch on this, this, and this, and this in the IO, and then we're back doing. So it's let me put it this way. Capacity management, one of the key pieces with capacity management, and Nick talks about this also, is one of my colleagues from Metron, understanding the data, understanding your environment. And you know that, yes, we're going to be running with 64 processors, but it has the capability of turning on 128 in there, in that machine. So you can so that's what I say, you have something in your back pocket, just in case.
Yeah, I've just been adding on to what John says. The PRA and the FCA, around the financial industry, do set down scenarios that the banks and the institutions have to set. So usually, I've seen it, they take those scenarios and transfer them to the situation you see by modelling scenarios beneath that. But some of these things are so extreme that you're actually planning for something much bigger. The key thing is to have the conversation with the business, to the line of business owner, so they understand those implications. So it comes back to a kind of a process and being in that loop to feedback.
Thank you for any other questions? All right, well, thank you very much